So, hi everyone. In this presentation, I'm going to show you how I analyzed millions of political campaign finance records in minutes using Spark. So, let's start our presentation. So, here in our FEC Campaign Analysis Pipeline, where FEC stands for Federal Election Commission. So, what usually happens is a candidate, let's say Donald Trump, declares his candidacy and he designates authorized committees which, on behalf of the candidate, raises the fund to be used in election campaign. And this raising of funds, the committee files reports to Federal Election Commission. So this is the official Federal Election Commission website. So here you can find the data. So this we can go through this, all candidates, candidate master, and so on. And it's at the same time it's categorized in election year cycle. So I will be using 2019 and 2020 data. So if we click on the description of this file, so we can see for all the data sets, we have column description as well. So I did create a documentation for this data, which I've uploaded in my Git repo. So, but let me go through my ER diagram so it will be easier. So here, let's say I have contributions by individuals data set, which simply means the individual contributor will be recorded here. So this is committee ID. This is the committee master. So this is my committee ID. And so these two tables are linked by committee ID. So the individual contributor contributes to the committee, and the committee master contains the information about the committees and candidate committee linkage, which links committees, authorized committees, to its respective candidates. So we can see here this this is the candidate ID and this is the committee ID. And so one candidate will have many committees, authorized committees, which on behalf of the candidate would be raising funds for the election campaign. And similarly, we have candidate master, which contains the information about the candidates. So here we have another data set which is transaction from one committee to another. So which simply means the inter-committee transactions. And this is the operating expenditure. So which we will be using further in our analysis to basically find out the trend of the uh, spending over the whole election commission cycle. So, and this is the political action committee summary. So here, so these are some of the insights which we will be going through, like finding total individual contributions by candidate, total and average donations by state, total expenditure per month, monthly expenditure trend over time, which I explained just right now, and total contribution in different buckets, like how many of the what is the distribution basically in the, let's say, amount bracket, 100 to $500, 1K to $5K, and so on. So Let's quickly go through the architecture diagram. So here I will be using my Dataproc cluster in Google Cloud. So this is a simple project. I will not be using any of the tools. So most I will be only using Spark for data ingestion, data processing, aggregation, as well as visualization. So we ingest data from Google Cloud Storage and two smaller data frames, which is the candidate master as well as committee master. Let me quickly refresh it. So basically, what I did is my candidate master as well as committee master, I have uploaded it in files.io. So I will be reading this data from my files.io SQL DB, which I created there. And rest all the data sources I will be reading from my Google Cloud Storage. So yeah, so these are the candidate master and committee master, which I uploaded in my files.io database, which I have created. Yes, so once the data is ingested, I will be exploring it and storing it in Parquet format in my bronze layer. And from the bronze layer, I will be I will be using this bronze layer data in my next step, which is data processing. And after data processing, I will be pushing the same data to my silver layer. And next, I will be performing data aggregation. So I will be ingesting data for aggregation from my silver layer. And after my after building my presentation layer, I will be storing it in gold layer and using at the last step, using Matplotlib, I will be creating visualizations. So this is my whole architecture of this project. So let's start with the notebook. So as you can see, I have opened my notebook, which is in the top of my Dataproc cluster, which I will be using. So let's start with my first, which is data ingestion and exploration. So yes, so before that, one thing I want to mention here is, so once you downloading this file from here, let's say if I click here, 2019, 2020, so it will download as zip file. Let me cancel it. So, so I have uploaded my zip file here in raw zip bucket, and I have used one utility function, file transfer utils, which I've created a code here which unzip the files and copies the data from raw zip to raw extracted. Yes. So I will be starting from here. So I will be ingesting data from raw extracted and I will be exploring it, check data leakage, and store it back in bronze layer in Parquet format. So let's quickly go here. So, so my first phase, which I did, is data ingestion and exploration. So I read the data, check the shape of it to check if the column count and row count matches the original reference values, so to check if there's any data leakage at the time of ingestion. And uh, next, I will be saving the data back in Parquet format. And I will be also performing some exploration in this step by generating some summary statistics and all. So one by one, let's go ahead. So this is my all candidates data. So I specified the raw extracted path, bronze path, and I uh, performed I read the data, saved it in Parquet format, and checked the shape of the data, as well as did some exploration, printed the schema, as well as generated some summary statistics. So this I did for all the data sets which is present in my Google Cloud storage bucket. And for the two data sets, which is candidate master as well as committee master, so I read it from my SQL DB, which I showed you here. So I used these credentials and I read it from my DB. So after reading it, I did the same thing. I saved the data back in Parquet format in my bronze layer and also checked the shape of the data and perform my exploration as well. So this is my first phase, which is data ingestion and exploration. Now coming to my second phase. So here I perform cleaning as well as transformation for my silver layer. So let's quickly go through that. So I read the stored data in Parquet format in my bronze path. So I did null values check in each column. I I performed some cleaning functions like trimming spaces and replaced empty string NA with none. So these are all my functions which I've created for general cleaning functions, which will be applied on all data sets. And for each specific data set, I have created a customized cleaning function. So here you can see, let's say, for example, all candidates TF. So here you can see I have handled null values in each column. Let's say candidate ICI with you. So if it's null, so I'll replace with you as unknown and so on. So this is the customized function which I've created for each data set. Now, after cleaning, what I did is, in my next step is I typecasted the columns to correct data types. This is also customized for each data set. So let's say for typecast, all candidates TF. For that, I've created this function. So this I did for all the data sets. And at my next step, I did feature engineering where I derived new features, aggregated and normalized my data. So for example, let's say in all candidates TF, I normalized state and district, basically converted it to uppercase so that it would be useful in my next step, which will be aggregation. Similarly, I add my, let's say, I added one column total receipts. So from where we have subtracted intra committee transfers to give us more accurate results. So similarly, total disbursements and performed same logic here. So uh, here we can see I have added some more columns like net cash position, cash delta, loan dependency ratio for each candidate. And here I've created one more data frame, which is geo aggregate data by geography. So basically by state, by district, we are checking the total receipts, total contribution raised, and so on. So similarly, we did for contributions by individuals TF. So this will be my main file, main data set against which I will be in my future visualizations, I will be using important uh, insights. I will be taking out important insights here. So let's say I have extracted year, month, week, state, and so on. So this will be useful in future for trend analysis, the trend of spending, and so on. So here I did this all feature engineering part for all the data sets. And at last, next step, I wrote all the process data to Parquet format in my process directory. So these are all the functions. And here at last, I applied all these functions for individuals data sets. So you can see for all candidates data, I started with cleaning, typecast, feature engineering. So one more thing I wanted to highlight here is, so if the data set is being used more than 2 times, so for that, I'm using caching to increase my performance. So after aggregation, I saved it back to my processed layer, which is my silver layer, and I uncached whatever the data set I cached during my pipeline operations. So this I did for all the data sets. Now, one more thing I want to highlight here is I also configured my parameters for Spark session in this session for the optimization performance. Let's say Spark SQL shuffle partition. So I've chose it at as 80 based on my cluster configuration since I have 8 cores, and by rule of thumb, by experimentation, we know that 10 shuffle partitions per CPU core is uh, 8 to 10 is good for uh, our performance. So I've selected several partitions as 80. Similarly, executor memory I've assigned as 5 GB, driver memory as 4 GB. And for each executors, I am assigning uh, 2 cores. So this is the optimization part, which I did in each of the phases. So my data cleaning and transformation part is complete. Now let's go for my data integration and aggregation part. So here I read the data from my silver layer. So mostly I will be focusing on some of the important data sets, which I will be using for my analysis, and I will be ignoring rest of the data. So, for example, candidate committee linkages, contribution by individuals, operating expenditures, and candidate masters. So here, what I will do is first inside I want to calculate is total contributions per candidate. So what I will be doing is I will be filtering by entity type, which represents individuals. So what I'm trying to do here is I'm trying to filter out only the individual only only the individual candidates, and I will be filtering out all the committees contribution and organization or big businesses contributions, and solely I will be focusing on total contributions by each individual candidate. So just to uh, check the ground level support for that candidate. So here I joined contributions by individuals with committee master, candidate committee linkage, and candidate master. So, which I showed you here as well. Let me quickly go through. Yes, so I will be joining contributions by individuals, committee master, candidate committee linkage, and here candidate master. So if we go back here I used broadcast join since committee master DF and candidate committee linkage DF and candidate master DF are smaller data set. So so we know if in order to optimize our joins, if one table is large and other table is small enough to fit in the memory, so in that case we will be using broadcast join. So here in my case, like candidate committee master, contributions by individual data frame is very large, containing millions of rows. So we did a broadcast join with this. So once the join is created, I cleaned join data. I, as I said, I filtered only the individual candidates and so on. So, and last, I aggregated the individual contributions in millions. So you can see I aggregated using sum and on the total individual contributions, and I rounded it to give me values in millions. Similarly, I aggregated donations by state and I mapped it to the state code to proper name for better readability. And yes, so I run the pipeline for total individual contributions per candidate and aggregate donations by state here. And next, I derived insight of campaign spending patterns month-wise. So for that, earlier I extracted year and month. So I first I mapped it to the month number to its corresponding month name, and yes. So once I run the pipeline, so here we can see we have year, month, and month name, and we have the spending, total spending in that particular month. So later on, we can see that I'll show better in this visualization part that like the trend was like it slowly, gradually increased and it peaked in October 2020, which was just the month before the election cycle, which is in November. So this is my donor analysis, frequency of distribution. So basically, I will be also analyzing who were the top end donors and also top uh, the frequency or top frequency of the donors, so who were more frequently donating, and donor distribution based on my buckets which I have created, like the bucket, let's say, between $100 and $500 and 501k, $501 to 1k, and so on. So after this, I wrote back my aggregated data in Parquet format back in my gold layer, and after that I uncached uh, all the data frames which I used earlier. So now let's go for my fourth phase, which I created, was data visualization. So which I did using Matplotlib and Seaborn. So let's go ahead and yes. So this is my visualization for total individual candidates, contributions by candidate. So we can see here, these are the top 20 candidates by total individual contributions. So Trump has most individual contributions, for followed by Biden, and so on. So I also calculated contributions share by party. So we can see here Republican has 50% of the share, followed by Democrat 48%, and rest other falls in 0.9% share. So now I also calculated total donations by state-wise. So here we can see California has the highest number of donations, which reached to 250 million, followed by New York, Texas, Florida, and so on. Also, we uh, can see average individual donation by state. So here, the District of Columbia has the highest average individual donation. So mostly people were donating between $350 and $400, and so on. So followed by New York, Alabama, Tennessee, and so on. Now, state-wise, what's the percent share of total contribution? So California has the highest number of share of total donations, followed by New York, Texas, Florida, Massachusetts, and so on. So here I calculated my monthly expenditure trend over time. So we can see that expenditure peaks in October 2020 because October marks the final month before the November elections. So election day was on November 3, 2020. So we see the expenditure gradually increasing as the election date is near. So, and it peaks to October 2020, which is the month just before the election month, which is November. So, and it sharply drops at in November, so which is as expected, because we will be spending just before the election date in the campaigns. So this is monthly expenditure comparison by year. So of course, the year in which election is going to happen, so the spending will also be more in the campaigns. So compared to 2019, 2020, we have high expenditure, and particularly as the election date comes near, the expenditure also increases. So here I have created heat map for the same. You can see in October it's dark. And yeah, so now next we calculated top 20 donors by total contribution. So we can see the top donor was Michael Bloomberg. So so he donated around between 140 to 160 million dollars. So he was the top individual contributor in the election, followed by rest of the donors. So let's go to my next distribution, which I analyzed is donation distribution by amount bucket. So as I said before, I created some buckets like less than $100, so 100 to $500, and so on. So here we can see the most people donated in the range 100 to $500, followed by 1K to 5K. Yes, so this was our whole visualization. So next, I converted all this code into my modular codes to be because this I will be running using Spark Summit in my cluster. So here, let me quickly go through my project structure. So here I created pipeline config.yml, which contains my configuration files, configuration entries for branch path, raw path, and so on. So for here, I've created my MySQL config as well. So yeah, so here I created, let's go first with ingestion exploration. So here I created this is my main file, ingestion run.py. So here I imported my all explore function as well as ingestion from GCS and ingestion from MySQL DB. I imported all in my ingestion run, which is my main file for ingestion phase. And I created a code for it. So here I also used logger, which I kept in my utility function, utility folders, utils folder. So this will be helpful in my debugging. So this I created for all aggregation phase, ingestion phase, processing, as well as visualization phase. So this is my ingestion exploration phase. Now similarly, I did for processing. I organized in such a way to organize inside cleaning folder. All my cleaning functions are there. Similarly, inside features, all my individual customized uh, feature function for each data set and so on. So this is how I organized it. This is for typecasting, and this is the general function, which is null counts, write parquet, which I kept in util. So this is my main processing run, which is for processing phase. So here I imported all the functions and I ran the pipeline for all the data sets here. So similarly, I created same thing for my visualization as well as aggregation. And at last, I created my pipeline run where I imported main run file for each phase, and I tried to orchestrate here where I first ran the ingestion phase, processing, aggregation, visualization, and so on. So this is the code, and this I uploaded it in my GitHub, in my source directory is present. So now in the next step, the last step, I basically connected to my master VM in my GCS, and I ran my all the pipeline run steps using Spark Summit. You can see here. So this is my logs, which is created. We can see here, so all the ingestion pipeline executed successfully, ingestion as well as processing, aggregation, as well as visualization. And one more thing, I also created test cases also, which simple test case it was, which simply checks the schema of my bronze layer. So I ran this as well. So yeah, please do check it out. I have uploaded all the codes in my FEC Campaign Analysis Pipeline repo. And yes, thanks for watching. Bye.